Thank you ever so much for the reception. What a wonderful looking crowd you are. So young and full of energy and curiosity. I'm so pleased to be here. Thank you for the invitation. Thank you all. I'm a professor of mechanical and aerospace engineering, and I teach with Python. I have been doing so for a long time. Against a lot of critics, of course. No longer. I won that fight. I'm also proud to be a Jupyter Distinguished Contributor, and I love Jupyter. I teach with Jupyter. I've been teaching with Jupyter for just over 10 years, in fact, when it wasn't called Jupyter and it wasn't even cool. But today I want to talk to you about Jupyter AI, teaching with Jupyter AI. And where does the idea of talking about this today come from? In November of 2018, I organized and hosted a group of 15 people to do a book sprint. We got together for 3 days and we put our collective experiences about teaching with Jupyter, and we wrote an online book about that, which is on GitHub pages with some sort of book format. And this effort has been recognized and been very useful over time. Mind you, this is 2018 again, so a lot of years ago. And it is now, in fact, 10 years since I gave a keynote at SciPy. This is a tweet from that time when Katie Huff was in the audience. And that's the time when I declared that IPython notebooks were, now renamed Jupyter, of course, the killer app for education, in my view. And the book sprint that I was telling you about in 2018, we put together this handbook, right, with 15 people that had experience teaching with Jupyter. And that was already 5 years after this event. And by then, Jupyter had become already the technology behind the most innovative educational programs, like at Berkeley Institute of Data Science. It had become the platform of choice for tutorials, for workshops and online lessons, and even books, right? Now we, I hope, all love Jupyter. So I've been thinking a lot that handbook that we wrote, we published in 2018, needs a lot of updating because we haven't. It's, a lot has passed, but we continue to be pleasantly surprised that folks still appreciate it. This is a recent tweet, in fact, where people still find it and find it useful. And I've even seen links to it from the library websites of other universities, so it's still useful. It actually is gathering citations even. But a lot has changed in the Jupyter ecosystem. It's come a long way. We have many new technologies that are especially interesting to the educational sector. And of course, I'm interested in that in particular. For example, Jupyter Lite, the ability to share Jupyter notebooks that run on the client-side browser, right? Making large teaching efforts scalable to other communities that might not have access to a Jupyter Hub or something that requires, a lot of billing with cloud providers and all of that. But the extension that I want to focus on today with an educational perspective is Jupyter AI. This is an open source project coming out of AWS under Brian Granger, who is one of the co-founders of Jupyter. And it was announced at JupyterCon 2023 in Paris just last year. So some of you may know about it, but perhaps some of you do not. So this is an active link in the PDF of the slides that I will share after the talk. I will put them on Fixture and tweet the URL so you can find the slides and you can follow the links to some of the things that I put on the slides. The announcement was followed by a blog post in August of last year with a few conference presentations and of course new features and updates since that early release. When it's announced, it's always a little green. Oh, okay. That was thunderstorm. And okay, we still have the video. So last October, I wrote a little tutorial for my students on using Jupyter AI, just the basics. You can find this online. So this is part of the open lessons that I publish for my students. I've been writing lessons for my courses, but I always teach what I like to say, I teach in the open, meaning everything that I prepare for my students, I publish so that you can take advantage of that as well if you find it. And I just share in the open source model everything that I am developing for the classroom. So this was a short lesson that I put out in October of last year, and I used it this past semester. I introduced it in my course for this engineering students that I teach with Python and Jupyter. And I'll tell you a little bit more about it, but I want to highlight some features about Jupyter AI. It's an interface to existing large language LLMs providers via API, but with no need to directly use the provider's Python package. Importantly, Jupyter AI is vendor neutral. And also, unlike other interfaces, it presents an opportunity for reproducibility because you can document your interactions with the LLM right in the Jupyter notebook. So your prompts can then, remain as part of your documentation of your work. I like that. I like, to have a record of the work, the whole workflow. Also, this is, when you interact with the large language model on Jupyter Notebook through a cell magic. I will show you that in a moment in case you haven't seen it. Also, it is transparent because if you generate code cells in the Jupyter Notebook, those are marked as generated, they're marked as such in the metadata. And also, it's convenient, it's very convenient because it provides this chat interface right in Jupyter Lab. So very soon, I began thinking about uses of Jupyter AI in teaching. In particular, the capabilities that it brings to carry out tasks in instructional design that can be accelerated by interacting with an AI model. So I wrote a demo that showed how to generate course learning objectives for the full course set, the full course catalog listed in the bulletin of the Mechanical and Aerospace Engineering Department where I work. There were 108 courses. So the bulletin, as we call it in universities, is this big catalog, right, that lists all the courses, and they have a course number, a title, and a very short description that is usually no more than 4 or 5 lines. And so the idea was if I could use this course title and description to automatically generate, or to ask the AI model to generate the learning objectives for me. So I wondered if I could sort of ease that task, which is a step that instructors need to follow when developing a course. We usually need to write those learning objectives. They then dictate that for each learning objective, we might develop an activity or an assessment that then starts building out the full course. Based on that first experiment, I worked on an extended demo for this talk today that I want to show you. I'm just going to walk through the Jupyter Notebook so that you can see it and perhaps think about the possibilities for yourself. This is all in a Jupyter Notebook that I share on GitHub. Mind you, it's not polished because I just have been doing it for this presentation. So it's got some typos and it's got some stream of consciousness, notes to self that I wrote down there, as I went along, documenting my work. But the purpose was precisely that, to share with you my process so it could illuminate the thinking that went into it. So let's have a look. I'm going to now just switch to the Jupyter Notebook, and I'm going to stop mirroring my screen first. So start mirroring my screen first, so that's going to change my resolution. So give me just 1 second to optimize for the resolution of my... Okay, so here is, well, I put it on GitHub, as I say, so it's already public. And this is just 3 notebooks, and I'll tell you what they are in a moment. And so this is the Jupyter notebook that I prepared in this experiment in curricular reform, I call it now. So there's a little bit of data preparation. We don't need to worry much about that. I got the bulletin. I got all the courses. There was more than 100 courses. I got the math courses that our students need to take, the chemistry, the physics courses. I put all that information to a text file. Then I have also some CSV file with the courses when they need to take them, because I was thinking maybe I can do something with that. But let me just skip ahead. All that data sort of cleaning and preparation that I did. So this is what the bulletin looks like. We have a title, a number, and a description. So I did a little bit of more, wrangling to eliminate empty lines and, my mediocre Python, forget about that, but it works. So, right, I cleaned out all of that, and then I separated, okay, I wanted aligned lists of course numbers and titles and descriptions. I did that, and then I separated other information that I didn't need, the credits and whatnot. Forget about that. I'm scrolling through this because it's not the important part. Here, I'm like, okay, what I want to do is I want to generate the course learning objectives of all these courses automatically with GPT 3.5. I'm cheap. I don't want to use GPT-4 yet because, look, I mean, GPT 3.5 Turbo, I don't know how much I'm going to use. This is kind of a lot. I haven't used it before, so I'm just going to go with 3.5. That's the cost, $0.5 per 1 million, the revised course pricing for recently. And I thought, well, maybe later I can try GPT-4 if I need, but that's going to bring it to $10 instead of $0.5, so I'm not doing that right now. Okay, when you use Jupyter AI, you still have to have an API key with the provider that you're going to use. Note to self, never leave that on a Jupyter notebook and push that to GitHub. Of course, that's not, there are better ways of doing that, but I'm kind of, I'm clean. I always come back and delete that. So, okay. And then you can start using Jupyter AI by loading the extension. Previously, hopefully, you have pip install Jupyter AI, that you can follow the documentation yourself. I don't need to tell you about that. So once you load the Jupyter extension, now you can use this AI magic for some line commands, or the double % AI for the cell magic. The syntax for the cell magic to interact with the LLM from a code cell in the Jupyter notebook is AI cell magic, the provider ID and the model ID, and then an extended piece of text that contains your prompt. So I'm going to prepare a system prompt that kind of puts the right context so the model knows what I want to do. And I wrote this long system prompt that I'm going to come back to in a little bit, but just note that it says that I will give you a brief course description separated by 3 quotes, and you will use that to generate 5 to 7 learning objectives which you will provide as a numbered list. Do not give a title, do not give a heading, do not explain, be clear and specific, and so on. I did my nice prompt there. I'll tell you a little bit more about that. And I did say the target learners are undergraduate students in a US university. All right. So I remember I have aligned lists, right, with course ID, course title, and description, right? There's more than 100 courses in those lists that I have in my session. So I'm going to try it with one of those, and I created a text here with the title and description. I'm going to now here call the LLM from the cell notebook using the AI cell magic, with the provider is going to be OpenAI chat, and the model here is GPT 3.5 Turbo, and I created my system, I'm creating my prompt there as a text where, of course, everything that is between the curly brackets gets replaced by the context of that string variable there, the system prompt and the text. The text corresponds to the course title and course ID, title, and description. And here comes out, for this particular course, that is titled Engineer Computations, the learning objectives. So I look at this, okay, apply computational thinking principles to model and simulate engineering problems. That sounds reasonable. Calculate numerical derivatives to analyze the behavior. Yes, that's good. Apply Fourier analysis at the end to analyze period. That's good. Those are perfectly good learning objectives. Now, when you are developing a course for the first time and you're tasked to write learning objectives, it's kind of like a bureaucratic exercise. Sometimes it's a little bit annoying, so to have this as a starting point, that's kind of nice. Now I can start thinking, maybe as an instructor, I will tweak this a little bit. Maybe it's not exactly right, but if it gets me 85% there, that's kind of nice. It saves me time. Now multiply that by all of the faculty in the department, it can save quite a bit of time. Okay, that's a description of that particular course. As you can see, there's some keywords there, but it's only 3 lines. And those are actually, if I compare those to this is the course I teach, actually, engineering computation. It's the specific course that I teach. So I can compare those learning objectives created by the AI model with the ones that I wrote, and they're not too bad. They're pretty close. All right, so let's file that. So GPT 3.5 generating a set of learning objectives and with the AI cell magic. But now I would like to get the objectives for all the courses in this way. So I want to run a cell magic repeatedly in a loop. And so for that, we can use the get IPython run cell magic command. The syntax is right here. Get IPython, run cell magic with the magic name, the line that comes right after the name of the magic, and underneath the contents of the rest of the cell. So how do I use this to call the LLM? Well, I'm going to get IPython, run cell magic. My cell magic, the name of the cell magic is AI. Then the line that comes after is ChatGPT. ChatGPT is an alias, I'll show you in a minute. ChatGPT is an alias for GPT 3.5 Turbo. -F is a formatting command to get my result as text, because I can, of course you can read all this in the documentation, but I have the ability to send some commands right there in the line next to the magic. And then the third and final input here is the combination of the system prompt and the text for a specific course. So I run that here in this cell, and I got the output for a particular course. Let's see, I don't know what the index was at that point, but I had, you will see that this notebook is a little bit out of order because this is my actual workflow. I've pulled it up here to show it to you, but I've had to do some things out of order for various purposes. Nevertheless, I've got here a process to call the cell magic to ping the LLM with a prompt from my Jupyter notebook, and I can do that. I'm going to be able to do that in a loop. Okay, so I have an extra note here for, if you look at my previous tutorial that I published in October 2023, I noticed that as I was calling this in a loop, the chat command through the Jupyter notebook was actually carrying a history of, so I very quickly reached the maximum context window. I didn't realize at the time that the AI magic was carrying, it had a history. Now that's been removed, so I left this note just to, because my old tutorial has that obsolete, deprecated command to reset the chat history. It no longer exists because since December 2023, they have changed, and now it removes the history, and so this is no longer needed. Okay, so note, why are we using the OpenAI chat provider? Well, because that gives us access to the models that we want. I could use just OpenAI as the provider, but that is only going to give me these models. The AI line magic allows me to use list to get for a particular provider what models are available. OpenAI/chat gives me all of these. That provider alias gives me all of these models shown here to the right, which includes Jupyter 3.5 Turbo and GPT 3.5 Turbo and GPT-4. We also have some aliases that we can use, and that's here left as a note to document the whole workflow. But here we finally have just this line here, this cell here that shows you the whole process. We're creating a list. I'm calling it objective, an empty list. I'm going to iterate through all the descriptions of the courses. I'm creating the text with the course title and the description. I create the prompt, which is the combination of the system prompt and the text prompt. I'm creating just a string variable to make it a little bit more readable and nice, and that is get IPython run cell magic with the AI cell command, ChatGPT as the line that comes after, and prompt as the full rest of the cell. Wait, something else happened here. What is it? Well, I want to not only run this in a loop, but I want to capture the output of the pinging the AI into something, maybe a file. Maybe in this case, I want to capture those into a list that is aligned with my other lists. So that I didn't document it in this tutorial, but I have it in my original tutorial that I published in October 2013. That, let me make that larger so you can see it, that we have another magic. The magics are indeed magic. Capture. Capture will store the captured output in a particular object. It has various attributes, a standard out, a standard error, outputs, and I had to go through a deep rabbit hole to finally found that the data that I needed was in outputs, but actually element 0 of outputs. So that's why I have here so I have two nested calls to get IPython. One is calling the AI, the AI cell magic. The other one is calling the capture cell magic, and it's grabbing the output the output here, this first element of outputs is going to be appended to the list objectives. And finally, I have what I need. Okay, this was a bit of an effort. I'm not, as good a coder as most of you in the room. But I managed to get that result. So now I have, in this second experiment, 100 sets of learning objectives for all my courses. It took 5 minutes and 3 cents of a dollar to generate through the API, the OpenAI API. It cost me more in October, by the way. It's cheaper now. All right, so I'm printing one to see what it reads like, and it looks perfectly reasonable. The handcrafted learning objectives for the course, my own course, are listed here, so we can kind of like compare. I don't know, look at this one, visualize data, so basic plotting, create data visualization using best practices. Okay, I put a little bit more there. I was thinking, utilize data visualization techniques to communicate findings and insights derived from computational problem solving. That's perfectly good as a learning objective to guide the process of designing a course down the line, for me as an instructor, for me as a faculty. Those two sets of learning objectives, importantly, might lead the person who's writing a course to very similar content decisions and assessment designs, which after all is what we need the objectives for. Many times you will go into a course as a learner and somebody lists the learning objectives there and you're like, why do I need to know? Let's get to work. You don't need as a learner to be told what the learning objectives are at the top of the course. That's kind of boring. We need it as educators so that we can design learning activities for you and assessments. Okay. So that's that part of the exercise. Here's another one, aerodynamics, calculate lift and drag forces on airfoils using potential flow theory. Perfectly fine learning objectives. I've compared them with the official syllabus that another professor created. The use of flow potential to model lift produced by thin airfoils is slightly different, but if I were to create a learning experience afterwards and write, an exercise or a little project, a prompt for students, it might end up looking very similar. So, in my opinion, after this experience, AI is perfectly capable of writing learning objectives. And why? Well, because really learning objectives, they're a tool for us to prompt us to write a nice course for our students, but they're not the pinnacle and the crowning glory of good teaching, despite what we might hear from folks at the teaching center. Okay, so I saved my work into a JSON file for future use because it cost me 3 cents, so I don't want to lose that work. And then I said, GPT-4, okay, I'm going to use GPT-4 to revise the work of GPT-3, and I'm going to check if this is any better. So I'm going to say, okay, you're a professor of engineering at top US University, blah, blah, blah. Task, I will give you a course learning objectives, and you're going to improve them. So I tried it with one. I got some new learning objectives, and they're kind of the same. I said, okay, GPT 3.5 is perfectly capable of doing this job. So I'm going to leave it there. So then I thought, what else can we do with this? I can, ping my LLM to do some tasks for me in a loop. That's great. So I've always, for a long time, been interested in the idea of embedding computing in the curriculum, in the engineering and science curriculum. Meaning, for the courses in calculus, physics, mechanics, fluid dynamics, thermodynamics, the types of things that we teach in engineering, wouldn't it be nice if we always had a computational approach? We were using Python to solve the problems. We didn't have to memorize or bring formula sheets, and we would be like using computation to visualize the flow, to visualize the results, to solve numerical equations computationally. I believe that would bring a lot of insight to the science that we're learning. So I've been talking about this for a long time, but I've had a lot of problems because when I bring this idea to my colleagues, they say, yes, that's a nice idea, but I don't have time. So unless I do it myself, which I've done for some courses, I have a hard time convincing, and for this to be really transformative, it has to be across the curriculum. It has to be ubiquitous because that's the way that you would graduate as an engineer, I feel, being also a good proficient user of coding of Python to solve your problems. So this also follows from a philosophy that I have, that you need to present coding in a contextualized format, meaning it always is nicer to learn programming when you're trying to solve a problem rather than mechanically just repeating patterns. I've left in the notebook that I shared for today some links to when I've written about that. So I'm decided to write a new prompt, and now I am feeling that I'm feeling more, I want to spend more money, so I'm going to use GPT-4. And I prepared a new prompt in which I'm going to ask the AI model to, what is the task? I will give you course title and description and the current learning objectives that I already created with GPT 3.5. And your task is to suggest 1 or 2 specific activities that align with the course learning objectives and at the same time provide students with an opportunity to apply computational thinking in context for the course content. Now, I'm giving here the AI my personality. I'm saying, you will favor activities that require programming using the open source tools of the Python ecosystem, and assume that the students are familiar with Python, NumPy, and SciPy. We teach that in the beginning courses. Remember, the activity should be achievable to the students as part of their coursework. It should not be so large that it takes many weeks of work. Explain how the activity can be broken down in steps. I have a mega prompt here to try to, again, create materials for me as an instructor to, in this case, offer my departments, my colleagues, an easier way into applying curricular reform to integrate computing, because, that's the modern way to teach, in my opinion. So here's another call to the AI cell magic. I'm using now GPT-4, and I'm getting for this particular test some activities. This is for, I'm afraid I've lost the link in my mental link to which particular course this is, but let's see. I've got an activity that says design and, must be aerodynamics. Design an analysis of airfoils in subsonic, design analysis of airfoil in subsonic conditions. And it says, oh, you can use Pygame to design a simple 2D airfoil, write a Python function to compute the velocity potential and flow field around the, okay. So I have an idea of an activity, okay. Then I have another idea of another activity for the aerodynamics course. And some of these may seem reasonable and some of these may not. For example, I did several tests with this. This is a previous activity in which, for the same course, in which GPT-4 told me that you could use an open source model panel method. I looked around, that doesn't exist. So it's a hallucinated, of course, that can happen. But this other one over here, PyFR, certainly exists, and it is an open source project to compute to work in computational fluid dynamics. So always, of course, so I leave here my notes. The panel method is likely hallucinated, and but it turns out that I have written a panel method for my course in aerodynamics, so I left the link there. PyFR definitely exists. So okay, then I compared it what GPT 3.5 might offer, and I found that GPT-4 was better. Okay, so either way, note, important, either way, the professor or a subject matter expert will need to review each suggested activity, particularly checking for hallucinated portions or incorrect guidance. However, we can use AI to get ideas on the table and to help instructors through the process of creating these materials for the students. So, for example, after I created those activities, I then exported my work to a PDF, to a markdown file, using some programmatic way, and then to a PDF file. It was a 132-page PDF file with learning activities for 100 plus courses that I could then, I sent an email to my colleagues only a couple of weeks ago in summer, so only 2 replied, nevertheless, asking, have a look at the learning activities for your course, tell me if they make any sense. So suppose that half of them don't make any sense, but half of them do. We still have some constructive material that has been presented to us to facilitate our work. So some note to self. Here is the code that does it for all the courses. I'm appending, of course, again, to list the output of running the cell magic capture, and that is capturing the output of another cell magic AI that is calling the model. So again, I did a little bit of checking, and I'm looking at some of the offerings of the activities that were generated. And now I have these aligned lists with course ID, course title, course credits, descriptions, objectives, and activities. The last 2 were generated by an AI model. I formatted this as Markdown, exported it, and have a result that I can share with my colleagues. There were a couple of things that I'm suspicious about. There were some results that I need to investigate that seem to have some pollution from other iterates in the loop. So I don't know if there might be a bug somewhere in my code or in Jupyter AI that is detailed. But I left my writings in the notebooks for you. If you find the error, you can help me out, or for me to go back to it and discover more about this exercise. Okay, so whatever, I saved a markdown file, and here are some comments that I got from my colleagues. All in all, I think this was a pretty good set of objectives for the class, just missing one key one that defines the hands-on flavor of this class. Okay. The suggested computational activities are not bad, although determining the cause of the Challenger disaster, one of the activities, could be a complex problem. It seems unrealistic, one of them. It is interesting that 3 of the generated ones match closely with the current course objectives, or some nuances are different. That's another colleague's response to when I shared the result of this exercise. The suggested computational activities closely match the activities that I already execute in the course, said one colleague. The only difference is the scope and so on. Okay, so I saved my work, all right, and from the experiment so far, It's clear, of course, that only a fraction of the computational activities that were generated by the AI model will be feasible. But even if it's just half of them, this is a wealth of material now that we could work with in a curriculum reform campaign. I'm imagining in the next faculty retreat, we could have a sprint with the 25 faculty in my department just work on this with this material and very quickly go over what is feasible, what is not. In the next step, I might actually pick the ones that are useful and go further with the AI helping me develop activities. So here's some examples for a mechanics course, simulation of a particle in a rotating reference frame. Is it any good? Analysis of vibrations, I like that one, analysis of vibrations in mechanical system. Okay, so what did I do next? I used the generate command, which, let me show you actually the welcome message from Jupyter AI. It tells me that I can use the generate command to generate a Jupyter notebook from a text prompt. Okay, that's interesting. So let me go back to my presentation. At that point, okay, so let me actually I'm not going to bother with my notes. I'm just going to show you what I did. So what I did is use the generate command with the prompt, generate a tutorial for an engineering course that consists of approximately the following. What is below, I copied and pasted from the result of the previous exercise, which was asking for computational activities for this particular course. So then Jupyter AI said, great. I generated, notice the timestamps there. It took 1 minute to give me a Jupyter notebook. That Jupyter notebook that it generated, let me show it to you. I didn't actually save the notebook. I made a mistake, but I did save an output of it into a PDF. So let me show it to you. It is this vibration analysis tutorial raw. Okay, so this is what it generated. Jupyter AI generated a Jupyter notebook, a file.ipynb that was saved in my root directory after 1 minute that had this, which is the prompt that I gave it. Then it had just this extra description right here that is, but it came out of the chain of prompts to the AI that Jupyter AI is doing under the hood. And then it gave me this. It gave me some sections to write a differential equation, define the variables. It gave me this. It gave me 3 sections. And let me scroll all the way down. It ends right here. That's, okay, well, I actually executed the code. It gave me code cells without execution, obviously. I executed them. I checked, executed them, and saved to a PDF. That's what you're seeing now. But notice that each one of these sections was consisting only of code cells, right? So this is kind of behind the scenes what some long chain acrobatics is doing, and it's generated some little description, and it gives me a set of code cells in response. So I look at this and I say, this is nice idea, but it's not that useful for me to use as an activity. For the students, obviously, I need to develop this. So what can I do next? So I have that, and what I can do next is select bits from that, open that generated Jupyter notebook, select bits from that Jupyter notebook, and then use the chat interface of Jupyter AI. Let me show it to you actually right here. So I could use the chat interface of Jupyter AI and say, select that, include selection, explain what this code is doing. And, well, actually, I'm still connected. I've had this session open for like 5 days, so I didn't know if I was going to be explained with okay, here we go. This is what the code is doing, and it's explaining each bit of the code. All right. So now I can do that for this. I'm going to go back to this file that I was showing you. For this initial Jupyter notebook that consisted of a description at the top and only code cells all the way down, I can start, as I'm the instructor, I'm responsible for turning this into a usable exercise for my students. I can now go and start working with generating descriptions for the code that is going to help me improve this Jupyter notebook so that I can use it for my students. And I could do that for every piece of code. I'm also using my head to check, that is what I want to do. And then at the end of that exercise, where I've generated a whole, using the chat interface of Jupyter AI, I can generate explanations for all of those raw little bits of code, and at the same time think about whether it's good, maybe change it, maybe edit it, and then I can use the export command to grab all that history of interactions with the chat interface interactions in Jupyter Lab, where I'm selecting bits of code from my Jupyter notebook, and it's going to generate a markdown file, chathistory.md. So then I open that markdown file, and I select bits of markdown, and I create markdown cells in my Jupyter notebook that I add all the explanations that were missing from the original result. And what do I get? After correcting the code for my preferences as an instructor and having the AI model help me, I get an 11-page PDF that now has this complete activity analysis of vibrations in mechanical systems with now explanations of what the code is doing, so I can provide this to my students in a way that they can follow it as a worked example, right? And it's actually more of a pedagogical tool. And I've made some changes in the code as I went along. So now this becomes a full worked out lesson that a student can use to learn how to do vibration analysis, where I'm first step solving an equation with SymPy, then second step I am going to be solving the equation numerically using finite differences, and I've got all of these explanations that come from my, and all of this eventually lead to a computational solution for the motion of a spring mass system. A perfectly reasonable activity that I could hand out to my students now as, maybe I can add some, exercises for the student, some intermediate steps there, but this is a perfectly good lab sheet now that I can give my students to maybe in a couple of sessions in a classroom complete an analysis of vibrations for the mechanics class. This resulting lab sheet, if we call it that, probably would have taken me to do from scratch with no help a week of work, maybe, if I'm the instructor. It would take a lot of effort. Instead, this took me about 2.5 hours from start to finish through these interactions with AI. So I feel like this is an amazing tool. And there's some other parts that I didn't tell you about that also now can help the learner, which is the ability to use retrieval augmented generation. So if I have a whole set of lessons that I've prepared as an instructor and I've shared with my students, these are shared in some folder. This student can then use the learn command in the Jupyter AI chat interface with a folder, and Jupyter AI is going to create a vector embedding of that. Then I can ask Jupyter AI some questions that are going to be grounded on those materials that were provided to the learn command. So for an example that I used here, I had left in some materials that I created for my students. It's kind of like a statistics set of lessons. I asked Jupyter AI about a challenge question that I had left there in the notebooks that did not have a solution, and it gave me the solution even with the correct variable names that I'm using in the lesson. So it's quite something. But I want to also highlight one important lesson of this whole exercise, which is that we, as instructors, if we want to use AI in our teaching, we have to remember to inject learning science into the AI. And the AI is not going to suddenly become this universal tutor that some people think about. Because if you notice, this system prompt that I created has some keywords that are important here. I'm saying here, you are steeped, this is a second system prompt that I prepared. You are steeped in the principles of backwards course design and constructive alignment, but are not attached to rigid guidelines thereof. Above all, you believe that active learning and in-context learning are best for engaging students today. I am there, when I'm saying backwards course design and constructive alignment, these are keywords about instructional design that are going to guide the AI to be in a certain context to provide to me more useful outputs. And just a random person might not have the subject matter expertise to provide a system prompt that is going to be that useful. So this is an important lesson to take home. There are other things that I like to use as my approach in lesson design. It's always good to break things and break things down into small steps that are achievable. It's always good to then chunk steps into bigger steps and add narrative, interleave easy exercises and add challenges. These are things that I have developed as an instructor to guide me when I create experiences for my students. And I have to use those research-backed learning science guidelines when I interact with the design. And let me just double check the time. Yes, I am in the end here. And so we've seen in recent announcements, this is from last month, recent announcements from the Google I/O conference. They had a lot of emphasis in education, and they are announced the LearnLM product, for example, and you see a lot of hype and a lot of flashy promises that AI is going to, provide these universal opportunities for education that, of course, are going to transform education, right? But as I think I've shown with this exercise, there's a wonderful opportunities that are being provided by this technology that we have available. But we need to inject learning science. We need the instructors engaged with using AI to generate better experiences for our students and still to guide them in their learning process. And I found just a couple of days ago this critique of the Google I/O announcement. This person from the On EdTech newsletter said, the education-specific AI solutions showcased at Google I/O were tech-focused solutions looking for learning examples, not learning-focused solutions looking for effective technology usage in pedagogy. In the longer term, educators will take the tools and apply them in ways that make more sense and address a real job to be done in interesting and unexpected ways. And so we need to be engaged as educators in the way that AI is being used in the classroom. Right now, a bit of the Wild West, but some of us are already thinking creatively about how to adapt to this new technology landscape. So that is the end of my talk, and I've shared everything, of course, online. I'm going to share these slides with you, and I'm happy to answer your questions.